Welcome to the lecture series of control system. In this session, I'm going to discuss most important questions from module 3. So kindly go through all the questions and make sure that before appearing the examination, you have to go through these particular questions. So as you can observe, there are a set of questions which are repeated several years. So that I have highlighted in the PPT. The first question from module 3, obtain the expression for time domain specification, namely the time constant. Okay, time constant, then rise time, then settling time for the first order system for the unit step input. Okay, so that you have to derive actually. Okay, that carries weightage of 10 marks. You should know the what is time domain specification. Okay, so what is the importance of settling time, first order system, everything you should know. Derive an expression for COT for the underdamped system for the unit step input. It's a small derivation actually. You should know from the basic derivation like C of S by R of S equal to omega n square plus S square plus 2 theta omega n S plus omega n square. From this expression, you can start doing the derivation. Then starting from the output equation CO2, derive the expression for peak time. Peak time means TP. Then peak overshoot MP for the underdamped second order system subjected to unit step input. That should be careful what type of input you are using. Clear? So these are the important questions. I wanted to continue. Few more questions I have noticed, and I just wanted to put you for your reference so that you can go through before entering to the examination. So moving on to the discussion. Yes, as you can see, write a short note on PID controller. PID controller. Okay, proportional, integral, and derivative controller. Explain the necessary and sufficient criteria of Routh-Hurwitz criteria. So using Routh-Hurwitz criteria, you need to solve the particular characteristics equation and check whether it is stable or not. Stable or unstable. You can predict whether the system is stable or unstable using Routh-Hurwitz criteria. It is also known as RH criteria. Sometimes in the question you may get like, what is RH criteria? So you need to prepare that particular column, there are some calculations available. So based on the rule, you need to formulate and finally you have to identify that whether the system is stable or not. So that is what you are expected to make out. Question number 7. So if I talk about question number 7, this is a question from like time domain specification. So first of all, you have to determine the second order transfer function. From that, you need to know the formula of peak time. What is a peak time? What is the formula for MP? From that, you can easily calculate the value of K1 and K2. Ultimately, I require the value of K1 and K2. So use this formula and definitely you can make out. Question number 8, determine the location of the roots with respect to the like S equal to pole, S equal to -2, given the characteristic equation S to the power 4 plus 10 to the power 10 into S to the power 3 plus 36 S square plus 70 S plus 75 equal to 0. It's a fourth order system. So definitely you can make out. Try to simplify it and you can find out the number of poles. Okay, it is not a big deal. It is very easy question only. Question number 7 and 8 is completed. Now I would like to move on question number 9. So if I talk about question number 9, so apply the RH criteria. You have to apply the RH criteria for the given closed loop system for the given transfer function. Okay, so you have to convert 1 plus G of S H of S, that is equal to 0. Use this and make out in the closed loop transfer function. Now you can apply RH criteria. So there is a most important question. In the system shown in Q5C, when subjected to unit step input as the output response shown in Q5C, determine the K and T for the response. Okay, so from this you need to identify what is peak time. So what do you mean by settling time? Okay, peak overshoot. Many parameters are given. So ultimately use the formula and you can find out the unknown parameters such as K and T. So that is ultimate question. Okay. So mathematically, you have to work out. Question number 11. Using RH criteria, may check whether the system is stable or not. So another one is also for the system g of s of s equal to k by s square s plus 2 into s plus 3. Find the value of k to limit the steady state error. Okay, you should know the value of steady state error. What is steady state error? What are the different conditions for steady state error? Then only you can make out this particular question. Okay, good idea about the steady state error is required. There are different formulas. Kindly recollect the formula. Okay, here that is also another similar kind of questions. You need to calculate the value of k. K value has to be calculated. So here you should know the good idea about the steady state error. So using the RH criteria, you need to solve this particular question. Check whether the system is stable or not based on the RH criteria that you are supposed to make out. So that is what exactly question number 14. So when it comes to question number 15, okay. So here again you are supposed to use the system is stable or not. Okay, using the RH criteria. So 1 plus g of s h of s that is equal to 0. From that you will be getting one transfer function. In that you take care only the denominator part. Question number 16. Please refer question number 16. When I talk about question number 16, a second order system which is given. So this is second order system. The rise time you have to calculate. What is TR? Formula you have to use. What is peak time? TP. Then what is the peak overshoot? MP in terms of percentage. So what is settling time? 4 by theta into omega n. From this here you can calculate omega n square. Omega n square is equal to 25. From that omega n you are supposed to calculate plus or minus 5. Okay, radian per second. Similarly, theta 2 zeta omega n is equal to 6s. S and S will be getting cancelled. So zeta you can calculate 6 divided by 2 into omega n. Omega n recently we found out. So like that you have to calculate the parameters. Later you can substitute in the problem and you can identify the answer. I think I have worked out the similar kind of problem for your lecture videos. You please go through that particular videos if you are recalling, collecting. Otherwise, I will share the link of that particular video. It will be useful for your university exam point of view. So let me know if you have any queries. Thank you very much for watching this video and keep patiently watching my videos. So if you have any queries, kindly update in the comment box. I'm happy to answer back. So any doubts, you can message me. So happy learning. Have a great day for you. Please go through these questions before entering to the examination. I wish you all the very best for your